My dear students, now we are going to look at decoder operation. How decoder works, we try to analyze. So before going to the decoder, what we try to see is how this decoder uh, look like, and from our previous knowledge, okay, I try to get the decoder. So as we have studied multiplexer, if I look at the multiplexer, how the multiplexer will be? Multiplexer will be like this. How many inputs? 2 power n inputs, 1 output. 2 power n inputs, 1 output, n selection lines. This is what exactly we have studied about mux. Now these are the inputs, of course. What sort of inputs? Digital inputs. This is an output, digital output. This is the mux that we have seen. Now there is a slight variation here, that is, which is what we can say is, from this what we have got is demux. How exactly demux look like? Demux is having n number of selection lines, right? Only one input, data input, and 2 power n outputs. So this is exactly 1 is to 2 power n. Now this is demux. Now these are selection lines, of course. These are selection lines, of course. These are n lines. These are n lines. These are 2 power n lines. This is only one line. These are 2 power n lines. This is only one line. Now from mux, what we have seen is encoder. From demux, what we are going to get is decoder. What is that is, if you could able to transfer these inputs, okay, these inputs on this side. But then the meaning of that is, I have a circuit with n number of inputs and one enable, then 2 power n outputs. These are 2 power n outputs. These are n inputs. This is enable. So n is to 2 power n. In case of encoder, what we have seen, 2 power n is to n, we have seen. In case of decoder, it is n is to 2 power n. Okay. So what I can say here is, the decoder is another form of demultiplexer, or right? Decoder is another form of demultiplexer. So now what we can do is, if we look at the decoders which are available commercially, they may come up with enable active low or active high. So I say enable, maybe active low, maybe active high. This we have seen already. Inputs may be active high, may be active low. What is this inputs active low or active high? It is something like this. If I take the decoder once again, I can say outputs like this, inputs like this, enable like this. I am taking 2 to 4 line decoder as an example, right? These are two inputs. So inputs, data inputs, say D0, D1, outputs Y0, Y1, Y2, Y3. This is known as active high inputs, active high inputs, whereas outputs, if at all you see, active low outputs, active low outputs. Okay, what is the other possibility? Is something like this. What is that is, I take once again a decoder, same 2 to 4 decoder, enable, two inputs. Example 2 to 4 line decoder. 4 outputs Y0, Y1, Y2, Y3. Inputs are D0, D1, enable. Inputs are active high, outputs also active high. So inputs, inputs and outputs are active high. Okay. If there is a bubble, then active low. We call it as no bubble, no bubble. We call it as active high, active high. Okay. There is no bubble in this circuit. So active high inputs, active high outputs. Now what is the other possibility? The other possibility is both can be active low. Okay. Inputs are active low, outputs are active high. So all four possible combinations. Okay. Possible. What is the meaning of that is, say I can have this is also active low, this is also active low. What exactly it will be? Active low inputs, active low outputs. Okay. Instead of that, I can have only active low inputs, active high outputs. So with this, I have covered four possible combinations. Okay. When we have two options, that is with respect to inputs, okay, we have two options, that inputs and outputs. So when we have inputs and outputs, inputs can be active low, outputs can also be active low. Okay, this is active low, but it is active high, outputs active high. Or what I can do is inputs active high, outputs active low, or I can have both active high, inputs active high, outputs active high. This is possible. Now we try to understand 2-line to 4-line decoder operation. So what I try to do is, I take up a decoder with two input lines. Sorry, 1 second. Inputs are here. Inputs are here. These are the inputs. Let's say I have enable. Enable is active high. D0, D1 inputs. Okay. I have four outputs. Y0, Y1, Y2, Y3. I take all active high. This is 2-line to 4-line, which is in general 2 to power n is to 2 power n decoder. So what I try to do is, I try to see the inputs enable, D0, D1. Then I represent the outputs Y0, Y1, Y2, Y3. When enable is 0, okay. So what is your output? Doesn't matter D0, doesn't matter D1, your output is 0. When enable is 1, okay. So D0 can be 0, 0. When it is 0, 0, Y0 will be 1. When 0, 1, okay, Y1 will be 1. So likewise we can see. So 1, when enable is 1, 0, 0, Y0 is 1, 0, 0, 0. If this is 1 and 0, 1, then 0, 1, 0, 0. When this is 1 for 1, 0, this is 0, 0, 1, 0. And this is 1 for 1, 1, this is 0, 0, 0, 1. So when input is 1, 1, which is 3, Y3 is active. When input is 2, Y2 is active. When input is 1, Y1 is active. When input is 0, Y0 is active. This is how exactly it happens. Rest all are zeros for active high output. So how can I see the expressions here? What is the expression for outputs? Say, let's say I have y0. How can I write the y0? Y0 is 1 when enable is 1, D0 bar, D1 bar. What is Y1? Y1 is 1 when enable is there, enable is 1, D0 bar, D1 minterm. Y2 is there, Y2 expression for Y2 is enable, enable. What is that? D0, D1 bar, D1 bar. Y3 is nothing but enable, D0, D1. So with this what I can do is by using 3, 4 AND gates I can get my circuit. So what I do is I'll take D0, I'll take D1, I'll take enable. Enable line is available, D0 line is available, D0 complement is also available, D1 available, D1's complement available. Now what I want? I want enable D0 bar, D1 bar. What I need to do? Give it to the AND gate. Then what I get is Y0. Similarly, you take enable, you take D0 bar, you take D1, connect it to the AND gate. Then what you get? Y1. Similarly, I can extend these lines, then I can connect them. You take enable, then you take D0, you take D0, you take D0, not exactly D0, you take D1 bar, then you connect it to AND gate. This will give you white. Similarly, you take enable, you take D0, this is D0, you take D1, connect them to the AND gate, this will give you Y3. So, inputs are enable D0, D1, outputs are Y0, Y1, Y2, Y3. So, we have understood the operation of decoder. Then we have did the design also. How we got the design? From input output relations. Okay. What input output relations we have got it? From these input output relations, we have drawn the circuit. Okay. So if you see this, these are the inputs, these are the outputs. This is what exactly decoder is. So we have derived a decoder, or I can say decoder design is done. So once you are provided with a name, just you know what is decoder. Operation is predefined. From it, we could able to understand the operation. We could able to make a design. Done.